Hello, Machinist! I'm Shogo Nakamura.
I'm Hiro Kuratani.
So, Hiro,
Yep.
today is new project. So, Unstop MachinisTalk.
Right.
At last YouTube video,
Yep.
I think the workpiece was a champion.
Right.
I never seen such
Yes.
multitasking workpiece. So maybe today is difficult to share new story, right?
Right. It's so tough for me.
Pushing,
Yes.
pushing.
Yeah, you are right. But actually, we find out a good like a component.
Oh.
Yes.
Really?
Yes.
Can you share?
Yeah. Sure. This is a component.
Oh, it's very complex, isn't it?
Yeah.
Maybe it's very precise and a lot of the process complex work.
Right.
Is this the semiconductor workpiece?
Right. This one is a semiconductor device workpieces. Very complicated workpieces. So, do you think about the cycle time for this component?
Okay. Cycle time?
Yep.
I think this is a lot of process, very complex. It's 25 minutes.
Oh, very nice.
Oh, really?
But actually, 12 minutes 45 seconds.
Big difference. What is that? I said it's 25 minutes,
right?
but
Actually,
12 minutes 45 seconds. That's a lot of big difference.
2 times almost.
Okay, Hiro.
Okay.
I cannot believe it.
No.
What is the material, Hiro?
This one is a stainless steel 303.
Okay. You have the material?
Yep. Sure. This
Oh.
one is the material.
This is the roundabout material.
Right. Diameter is 50.
Wow. This is not made by the near-net shaped material. This is made by roundabout material.
Right.
Wow. It means from material to complete workpiece. Wow. All machining.
All machine, yes.
Incredible. And then 12 minutes 45 seconds.
Yeah.
I cannot believe it. Is this, I think, it's a multiple type of machine we need. 3 machine, 4 machine?
No, just one machine.
One multitasking machine.
One multitasking machine.
Okay. I want to see now.
Okay. Shall we start?
Yeah, let's start. So, stop.
Yep.
Firstly, this machine is 3 turret machine.
Right. 3 turret machine. 2 upper turret and 1 lower turret.
Okay.
And left hand side spindle and right hand spindle. The name is NTY3-100V.
Oh, NTY3 100V.
Yes.
What the meaning of NTY3?
NTY3 means the 3 turret y-axis.
Okay,
So all 3 turret has y-axis,
understand.
and 100 means about 6-inch chuck.
Hmm.
The normal size of the diameter, cutting
Okay.
diameter.
So normally, this machine
Yep.
can cut 100 millimeter diameter wise workpiece.
Yep.
And how much maximum turning diameter?
200
200.
millimeter.
Okay. And what the meaning of V?
V means velocity.
Oh,
It's a speed. Our target is a high speed,
faster than fastest.
faster than fast.
Okay, so let's start again. So this is a simultaneous upper and lower turret OD cutting. Stop! So now we done this machining, this turning and upper and lower
Right.
turret simultaneous machining.
Right.
So it seems to be upper turret, so 2, and lower turret 2.
Yep.
The position is a little bit different, have the gap
Oh,
on the Z-axis
Yeah.
direction, right?
Good
What's
point.
the meaning?
Yeah, good point.
Oh.
So that one is upper is a little bit faster starting position, and lower is a little bit behind.
Okay.
Cutting together, then making the component. Even if we try to same like a starting point,
Yeah.
in that case, very difficult to control like a geometry data.
Mhm.
Must be 0. But we cannot do that 0.
Okay.
So we decide to like a cutting up and lower is a different diameter.
I understand. So that kind of the cutting method,
Yep.
very small demerit. So because in the cycle time, it's not a big difference, just a little bit gap.
Right.
and then reduce so much risk.
Right.
If the same position start, the position adjustment is not enough. What happened?
Just one side cutting, the other side the air cutting like that.
Oh,
In that
that's a
case,
huge cutting load on
Right.
the turret.
right. Just one turret has a huge load.
Oh, I think this is very efficient, very low risk. Nice idea. Okay, let's start again. So, what the next? With the upper and lower turret mirroring
Simultaneously, yeah.
simultaneously. So this mirroring process in the using y-axis, right?
Right.
Okay, let's stop. Stop! So this turret is start a different position and then move like that.
Right.
So why this movement?
So this is very good point. Actually, if you try to cutting like a same like a starting position,
Yep.
up and down like this, in this case, the workpiece is bending a lot.
Okay,
Then this time is cutting here, so materials keep the same position,
understand.
no like a stress.
Okay, understand. So if the same direction
Yep.
in the same position,
Yep.
with a huge cutting load on
Right.
that direction.
Right.
But if the different position, so move together, and this is a balance.
Balance,
cutting
yep,
load.
right.
Okay, understand. It's very well. Okay, let's go. So this is mirroring and the flat mirroring processing on the upper and lower,
Yep.
and here I think.
Yes, yes.
And
Right.
this is the end mill process on the contouring
Contrary. Yep.
and make here.
Yep.
Then center drilling. It's quite fast.
Right.
Milling speed is 10,000 RPM.
Right. 10,000 RPM.
So I think the turret is compact
Right.
and it's higher RPM, 10,000. So this is a very unique. Stop! So what is the point for the compact turret on the high RPM?
Yes. Actually, compact turret means very, for example, gripping the workpiece here, very close to the chuck area.
Oh, I understand.
Then no interference.
Okay,
Many cutting is possible without interference.
understand.
And also our mechanism is quite nice, shorter area and nice like meeting like driving devices inside.
Okay, technology.
Technology.
I think there's a lot of secret,
Mm.
but the point is the compact turret can cross to the edge of jack.
Edge of jack. Yep.
And for example, like the cross mirroring,
Right.
if we check here,
Yep.
and turret can move there,
Right.
and no offset touring, and that is a keep accuracy.
Right. No special meeting holder the necessary.
Oh,
No.
That's important point,
Yeah.
I think. Okay, let's start. Okay, the simultaneous up and lower drilling.
Right.
Oh, is it interference?
No.
collision?
yeah.
Looks like that.
Yes. But it's not. Y-axis offset. This falling here and
Okay.
crossing here.
Okay. So the lower is a 1 millimeter end mill.
Right.
It's a very precise one.
Right. Then
And the
the
chamfering, what is that? So please stop it. Stop! So chamfering 10,000 RPM. So what the point of this process?
lot of human relation for chamfering.
Okay.
In that case, machine can making all of the chamfering by themselves.
Oh. And also it's high speed.
It's also high speed.
So we always propose for the customer and inside the machine,
Yep.
chamfering and deburring. So buy the tool, right? And then customer always say, if including such process additionally, so it means it's a longer cycle time.
Right.
Customer always concerned about time. But these 10,000 RPM,
Very fast.
wow, it's make shorter
Right.
time for the chamfering.
Right.
And we can do automate. So it's difficult to hire the people in all over the country. It's difficult to hire the deburring and chamfering
Right.
workpiece by hand. So I think it's a nice idea. Inside machining and faster chamfering.
Completely.
Wow, nice idea. So let's start again. It's super fast. Huh?
A lot of power here.
Stop! Okay, Hiro. So this chamfering process programming, I think made by CAM. Is it right?
No.
No?
Yes.
Really?
No.
Definitely need a CAM.
Yeah, our operator used Nakamura-Tome original software, NT manual guide I. That one is using.
So NT manual guide I is our conversational
Right.
programming system. So the screen, the question,
Yep.
the something, and we just input the information. It's very easy. But also we always use a CAM for complex the workpiece.
Yep.
But also we need to pay the money for CAM.
Right.
If the part of this chamfering process made by the conversational programming is very, I think, reasonable way.
Right.
Oh,
For you and the customer. Yes.
Impressive. Okay, let's start again. Then, rice spindle process start. End phase turn,
Yep. They're starting.
maybe here. And then, end the mill process. The milling process on the upper. So, then lower turn process start.
Right.
Then simultaneous milling operation, upper and lower turn.
Yeah.
So, stop. So, it seems to like 3 turrets operate at the same time.
Right. So the 3 turbines working together.
Okay. In multitasking, all units must be busy.
Busy.
So, what do you think about process designing for this workpiece? And left and right spindle cycle time, the right spindle cycle time longer?
Right. In that case, the lower turret
Yeah.
working for the right hand side.
Okay. So upper and lower milling operation in the short end cycle time on the lower,
Right.
on the right spindle
On
process.
the right.
Understand. So firstly, we make the both spindle process by programming, and then calculate the cycle time. If the right spindle or left spindle process is longer than the other spindle,
Yep.
it means we have the potential to shorten the cycle time by upper and lower turret. That is a supporting function
Right.
on the lower.
We call the pitch turning or the pitch milling operation.
Okay.
Pinch
okay.
milling, pinch turning operation.
Understand. This is a very important process for multitasking machine.
Right.
Understand. So, start again. So, 10,000 RPM
Right.
and end the mill process.
Upper and lower.
So, center ring again. Wow, right spin the process, the many 10,000 RPM process.
Almost 10,000.
Yeah, it's very fast. What is that? Hiro, stop!
So this one is the M3 rigid tapping operation. The cutting speed is 4,000 RPM. Go in
Okay.
and come back 8,000 RPM.
Wow, what is that? Very fast. Either 4,000 come in, 8,000 come out.
Yep.
So it means the returning the RPM
Yep.
is a double
Right.
to enter in,
Right.
meaning RPM is double.
Right.
Before this machine, before V3, so we offer around 1,000 RPM
Right.
for the rigid tapping. But now, 4,000 come in, 8,000 come out. What is the difference?
Because we made a fine adjustment for the V series for synchronization.
So this is the axis travel
Yep.
for x-axis, also the milling rotation synchronization. So the accuracy is very important. So in the V series, we developed the fine-tuning adjustment for this synchronization.
Yep.
Then we can do this one.
Right. Right. You're right.
So I think this is one part of the ChronoCut technology. Great. So let's start again. This is tapping super fast.
Right.
Okay, so right spindle operation also finished. Then after that, how to eject the complete workpiece?
Yes. We have the parts catcher G type.
Ooh,
So G means gripper.
gripper.
So after making a component, move the gripper here to pick up here.
Okay.
Remove and move back
Yeah.
to the conveyor area.
Yeah.
After that, conveyor move to the outside of the machine.
So I think this workpiece is a semiconductor workpiece.
Right, semiconductor workpiece.
It's a very precise. So I think the scratch is a prohibited. So that is a gripper type is very matched.
Matched, yes.
So the gripper is seem to like the blue jaw.
Yeah, blue jaws. Yes.
That is, we can change this jaw for the multiple type of the diameter or workpiece.
Yes, but we have like some of the range
Okay.
until 65 millimeter workpiece is grippy.
So normally bucket type have the risk of scratch.
Right.
So but the gripper type is, I think, in the very few risk of scratch, and for the precise workpiece is very much I understand. So Hiro, I was surprised. This is automated by Barfield and Patrick G in one multitasking race, NTYC100B, and cycle time is 12 minutes 45 seconds. It's incredible. So everybody, let's cut the body of manufacturing with multitasking machine. If you like this new project, please subscribe and press I rating. If you input your comment, we check all the comments. So please input that. See you, machinists.
Bye
Bye.
now.